You can switch on your microphone.
Oh, now I'm online. Okay.
Yes.
So, also hello from my side, and thank you, Ilio, for the introduction. And so it's a pleasure now to show you the new features and improvements, actually a selection of them, the new release was published and is available since a couple of days actually. It was published on April 2nd, so you can find it now on our homepage, on the KISSsoft homepage, and I will start right away with this topic. I will start how can you update your KISSsoft to the latest release. Before doing that, just some words as an announcement. In the end of this session, we kindly ask you about your opinion and your selection of your most favorite 3 features which you like most in the new release. So please pay attention to all of the features we present you and give us your feedback in the end. Okay, so but now let's start. And I will start how you can get the new release. You may know the My KISSsoft area on our homepage. So if you log in to the My KISSsoft area, you will find the customer area, and within that customer area, you will find your license, and now you will find the new release available. On the right-hand side, there is the download for license file and software for you available. If you have any problems to get into the My KISSsoft and the customer area, we have an instruction ready to you. And also an important note is, of course, you will only see the new release if your license is under maintenance. So if you want to have your license under maintenance, or if you have troubles with My KISSsoft, please contact your local KISSsoft partner. They will be able to help you. Yeah, beginning for the new features, I will start with general features. There are sometimes smaller features which are quite nice and quite helpful in the daily work with KISSsoft software. One of these is the tables. We introduced now with the new release tables which you can call and open from the header, and we prepared typically 2 sections or 2 tables, one for geometry, one for strength. And in the tables, you will find, and they are marked, as you can see here, with a small icon representing a table. They will provide you with input data, but as well with output data. So I want to show this right away in the software to you. Let's say we have an bevel gear calculation, and here we can find now the new feature, the table. To be honest, the tables, we got inspired by the KISSsys software. If you remember, in KISSsys there were the tables available, and we did so now for the KISS design module, and we said in the same, hey, why not to have them in KISSsoft? And this is how it is today. The KISSsoft machine element modules, almost all of them, they have tables available, which are quite a fast way to get informed about the current results and to double check that the input data are as as we wanted to have. 2 comments about it. What you can do if you miss a parameter today is either you can call us to KISSsoft and say, please implement also gear mesh losses, because I would like to see gear mesh losses especially. Or a second possibility is you add it by yourself. So this parameter, the gear mesh loss parameter, I added by myself, and this is possible. So we designed the tables in a way that you can add. Also, it's possible that you add your own table as well, which you customize specifically to your needs. In the PowerPoint, you will find here a short or one small example how you can do that. So it's not so much of programming, and typically, as we do, to be honest, as a user, we use a copy and paste strategy to get it on easiest way. A second point I want to show you is that the zoom functionality for 3D graphics now also considers a centering or a pan functionality. And this is a small feature I personally like quite much. So for example, we have a bevel gear display or a bevel gear 3D graphic, and we want to see specifically here in the meshing some details. So now it's possible that with the position of the pointer, it changes also the center of the objects, and that's a nice feature. So we don't need to pan and zoom separately. As a next topic, I would like to talk a little bit about the KISSdesign module. As you may have heard already, the KISSdesign module is the successor of the KISSsys system software, and we already did a presentation about functionality, about introduction to the KISSdesign module in a previous webinar. This was done on March 5th, and these recordings are available on our homepage. That's also the reason that today I will not talk too much about the KISSdesign module, as it is already presented, and we also have little time beside the KISSsoft machine element functionalities I would like to show you. Just to remind you, in this presentation, what you have in front of you, you will find a collection of slides showing many possibilities in the KISSdesign. Here currently I only have a small reduced selection of the slides. What you have, for example, about topologies which are feasible to do with the KISSdesign, or about operating conditions which are available now if you have, for example, hybrid drives. The result data tables, bar charts which are available within KISSdesign module, and many more. So this was a really reduced number of slides, and now I would like to continue with KISSsoft machine element features. Talking about cylindrical gears and geometry, as a first topic, I would like to mention especially about the GDE export functionality. The GDE is a standard or a guideline which starts to be more and more present for manufacturing companies, and we already have in the release 23, we used to have the version 3.2 in the KISSsoft. Now, as we faced feedback from many customers saying, oh, my machines, they only have version 3.1, so we decided to add the previous version 3.1 as well. Let's have a look at the content of the GDE, which stands for Gear Data Exchange. What is the content of it? It is, first of all, the basic geometry, which means macro geometry. It also contains the tool, such as hub and pinion type cutters. It contains some measurement data, and it contains also some modifications. So, and let me give some words about modifications. Here we can see modifications which are directly supported as a type in the GDE XML file. But as in real life and in your designs, you may have many more modifications than only that ones. There is the option to export all the modifications as a so-called design profile or design helix mode. And what does that mean? We can see here an example when a modification is exported as a design profile mode. We can see that in the K chart we can find the profile modification starting at that roll length position and heading up to the tip. We can find then in the XML file, we can find the same in many small sections. So starting from the very root position with a length and an amount, and going up to a higher position here. So in that one it was easy because the amount was simply 0. Yeah. So we have this profile modification described in quite some steps only. Let's have a look at it in the software. For this, I prepared a typical high contact ratio gear, and let's say we want to export it to your metrology center or to any other machine. How does it work? In the module specific settings, so here we can define about the format, and we can define how the modifications are exported. Currently we do as design profile mode. And when we now look at the modifications, we can find here one lead modification, a flank crowning of 8 microns, a tip relief, and a profile crowning shortened. Let's do now that export. Let's go on version 3.1. And let's have a look at the file. As I said in the beginning, it contains a section of macro geometry such as number of teeth, normal module, and so on. And now we find the profile modification with the many small sections which are the same as the K chart of the profile diagram. Here we can see the same values in the graph. Vice versa, when we export the gear data with the, and this is pre-prepared, so with the data with the mode of exporting the modification as a type, we can find the helix modification, the lead modification with the 8 microns specifically. So this is how the GDE format handles the many types of modifications which are possible, but which are not covered by the guideline directly. Okay, this was about the gear geometry. Now I would like to continue with the gear strength topics. First of all, in the release 24, now it is available to have the calculation of case hardening factor. The case hardening factor describes the properties of the gear pair if the case hardening depth is not optimal. It is either too shallow or it is too deep. What happens is that the permissible stresses will be reduced. Let's have a look at two examples or two cases. In one case, hardening depth is too shallow. It means the entered hardening depth, minimum to maximum, is closer to the surface than the optimal hardening depth. In that case, the T-min value will be used to calculate the case hardening depth factors. On the case 2, we find that the case hardening depth or the hardening depth is entered or is considered to be deeper than the optimal case hardening depth area. And in that case, the value of Tmax is considered in the factors. And finally, what happens if the area is larger defined in KISSsoft than the optimal value? In that case, the worst case will be considered. Let's have a look in the software and how the handling is in the software. You will find the case hardening depth factor in the tab factors and there in the section ZY factors. Here a checkbox is provided so that you can click and you can activate the consideration of the hardening depth factor. In the plus button, you can define directly the hardening depth values as min and max values. And when these data are provided, we can find in the report in the strength section. So we can find here the new parameters for case hardening or case hardening depth, the YCHD. So this is how you can handle in the KISSsoft software. Besides that factor or that calculation, we also updated other calculations just to provide you the most current possible calculation algorithms. Also, plastic material data are updated, and also an own input for life factor is possible now. A topic I would like to spend some more time on is the FE calculations for tooth root stresses. We worked quite majorly on this topic for the release 24. What I want to emphasize especially is that now the mesh is created based on a specified algorithm developed by KISSsoft. So we have now a mixed FE mesh using tree and quad elements. Let me directly go to the KISSsoft and to an example to show that. So here again, we have an helix or a helical gear, high contact ratio gear, and we would like to check about the tooth root stresses first in 2D, and this is a typical application. When we look closely to it, we can find here an grinding notch, and we would like to elaborate closer on that stresses which are occurring. So therefore, we have now the possibility to select an appropriate mesh density. Let me show you, starting from 1, which are quite coarse mesh, but going to level 7 with a very fine mesh. And you can see the graphic update instantly. So this is a very quick process now. When we want to calculate the root stresses, and I just selected here the highest mesh density, and you can see how quick actually now the calculation works. We will find then the results in the graphic, and typically it's quite helpful to see just visually how the stresses distribute in the root area. And indeed, we can find that the grinding notch generates higher stresses than the root area, which was used for the design calculation as per standard. So in this case, it means the design engineer needs to pay attention, especially on either grinding depth or the grinding stock or tool radius to avoid higher stresses. Based on the 2D FEM, then we improved also the 3D FEM calculation majorly. We can find now that the number of teeth can be selected between 5 to 1, and mesh density can be varied in the same as before. And I will start now the calculation, and the calculation you will see requires a contact analysis. While the calculation runs, I will explain you about the background. So the algorithm in KISSsoft is so that the line load, which is used for a 3D FEM stress calculation, the line load is calculated in the KISSsoft contact analysis. And this has the big advantage that we can use a very fast process in the contact analysis and apply this result of the contact analysis to the FEM, which is then overall a much faster process. Here we are with the result already. You can see the red line. So the red line representing the line load, and we can see the FEM results, which show us a clear effect of the line load, and also including then the modifications which are applied. One more feature we implemented here is to have the selection of the angle of rotation. So it means per default, the software gives the line load applied on, let's say, on the resulting with the maximum bending moment, but the user is free to choose any other line load as a considered load for the FEM. So here we think and we believe that the module in KISSsoft is on a level so that you can save your time to do an external FEM calculation by any other software, and you can save a lot of time to recreate the gears and the loads in a separate software and a separate process, calculation process. So coming back to presentation, you will find a description also here on various slides. I want to continue now with planetary gears. In the planetary gear, we can find an additional mesh load factor calculation according to ISO standard. Now I come to bevel gears, and in bevel gears, we did quite some standards, quite some work for updating or introducing standards. First standard I want to mention is the ISO 10300, which is the strength calculation. So the strength calculation contains also examples, means one bevel and 3 hybrid gear examples, and we can see that the KISSsoft results match very precisely with the results from the ISO standard. From the content side, there was some modification in the contact stress calculation, but to keep it short, the safety numbers on the pitting calculation are very similar as before. Also, there were some improvements in the standard here and there. So this is now available in the KISSsoft software. Another standard I would like to mention is the DNV Germanisch Lloyd certification guideline. And here we added in release 24, we added a possibility to define tool crowning directly in the KISSsoft software. And with that, also we finalized a comparison and the comparison work also together with the company DNV based in Norway to have the KISSsoft results as close as possible to the DNV software results. A third point in the bevel gear standard is the tolerances, the geometry tolerances, which was launched from the DIN standards last year, and we implemented, and in the same, we also want to give you as a user the possibility to have the current edition, means the 2023 edition, or the previous, means the 1986 edition. Sometimes machines, measuring machines, or of course your specifications, they require to have the values of the older edition as well. One point in bevel gears I would like to show you in software. It's about calculation of phase load factor and calculation of misalignment values. Therefore, we start with an example file, what we have in the KISS design module. So it's an industrial transmission. And the first stage is a bevel stage. And we want to look now at the phase load, distribution of this bevel gear contact, considering the shaft deflections directly. So therefore, I go into the KISSsoft calculation, and this is the bevel gear calculation, and in the tab factors, the new section of phase slope factor is introduced. Here we have the selection for own input for calculation according to calculation method, and new is or are the two methods also considering then the displacements using shafts. And the fourth option is based on an approach which is well known from the cylindrical gears. So when now starting the calculation, this approach allows to consider the current shaft bending for a specific load, including also the modifications which are defined in lead or profile direction. And it will result in the load-dependent phase load factor and in the load-dependent EPG and alpha values. Furthermore, these data can be exported by an XML file to the GEMS software. The GEMS software is the bevel gear manufacturer software from Gleason, which allows a very detailed analysis of the manufacturing process and also has further possibilities in contact analysis of bevel and hybrid gears using a full FE approach. Coming back to some more improvements in bevel gears, we also could improve tooth contact pattern calculation, especially when using misalignment values. We could achieve now a much closer match with the reference software, which is Cage and GEMS in this case, for a straight bevel gear and for a spiral bevel gear. So we are happy to achieve or having achieved major improvements in the KISSsoft contact pattern calculation. Also for differential bevel gears, where we can see some increasing demands from the designer side, there are some improvements done for the current release. Let's have a brief look at the crossed helical gears. Also there, we added some improvements. I want to mention about only one, just representing the improvements for crossed helical gears. So for example, you can now display a path of contact, which gives a better insight about where the contact happens, also for non-90 degrees shaft angles. Let's have a look at the gear types, the worms with globid worm wheel. Therefore, I want to go directly to the software. In parallel, you can check about the slides in the presentation. For the worm with globid worm wheels, there is an improvement done in the fine sizing. So in fine sizing, there is the option added to do a spacing of the bearing distances for each of the solutions calculated. Let's have a look at it, what happens. So if we unclick the option, it means as it was in the previous releases, and we calculate all the options, all the solutions, and we go on graphic, we can see there is no variation in bearing distance, we get a result which is represented here. Vice versa, when we activate the individual sizing of bearing distances, we recalculate. So we get, with the same settings, we get the results of the varying bearing distances between 120 to 240 millimeters. And we can also see a clear display of the properties. So we can see the safety for the deflection dropped significantly because of the higher bearing distance on the worm. So this is a very reasonable result and gives a quite a good and quite a complete display of the properties. There were some other improvements done. You can find in the presentation, but I will skip for now. I would like to continue with the shaft calculation. Shaft calculation, first of all, we also and continuously want to improve the shaft editor and the handling. As you know, starting a shaft calculation means modeling the shaft in the shaft editor. So for a simple shaft calculation, this is very comfortable and very easy. For a complex coaxial shaft, as we can see here, which is a multiple planetary stage coaxial shaft file, it gets a bit more tricky, and we wanted to give some improvements here. So let's have a look into the software directly. You may remember when you wanted to select for a coaxial shaft, when you wanted to select a shaft, it is possible to define levels. It means this describes, the level describes which shaft is in front of any other shaft to be able to select it more clearly. In this example, I don't specify any levels, and still you see I can click into the bores, and the bores are actually, or the selection of the shaft is defined now so that the bore with highest diameter will define which shaft is selected. And this is actually now very comfortable and very convenient to handle, so that I, by one click, get the corresponding shaft selected. Some more features are available. For example, if you double click on a cylinder, the complete shaft is selected, or if you double click on a chamfer, for example, by double click, the cylinder element is selected. So it is worth to play a bit in the shaft editor and to find and to explore about handling improvements in shaft editor. As a next point in handling is that we added now lists to select the bearing seats directly. So as you know, you can define bearing seats here in allowance or tolerance, and now there is a drop-down selection available to choose the corresponding seats directly. This was about handling. Let's have a look at some strength calculation. The first point I would like to look into is about reliability of a shaft. And the reliability of a shaft now is improved and more precise to have the reliability as a product of all the cross sections. So this typically you will need the reliability calculation you will need for shafts which are calculated in the limited life strength. For example, you wanted to calculate the reliability for a shortened lifetime test on your test rig. So you don't want to spend months and years for an endurance test. So you want to have a higher load applied, and you want to double check on what is the comparable lifetime using higher loads but shorter time. So then you are typically in a limited life area, and you will find now the reliability more precisely is calculated in the section of service life and damage. And here you can see the reliability of the individual cross sections and then the reliability of the complete shaft smaller than the individual cross sections. And this gives you a more precise prediction of reliability of the shaft. Let me continue, but only on the presentation side, about some additional improvements in shaft calculation. Now you're able to select a specific load bin for strength calculation, same as it is for the gears available. Then also additional options for the Wörderline or SN curve is provided now. And one more feature I would like to show you in the software is now. Let's have a look at a typical fine pitch transmission. And therefore, again, I start on the KISSdesign module on system level. And you will see now a transmission which is typically applied on fine pitch. So having the very high overall ratios, ratio 1000 or larger. And then you're interested in the power losses of the gears, but also of the pins supported directly in the housing. And the power losses you can calculate here quite comfortably. I just need to make sure that the units are appropriate to see the corresponding values. And how to get to the losses of the individual shafts is now a new feature in the current release. We can see now on the right hand side various options to define the support. And please watch on that symbols, because when selecting other support types, we can find also represented by other symbols which are easy to read. And in the same, we can also define, or user can define directly, coefficient of friction. And this is then also given in the report. As typically in the report, you're interested about the mean surface pressure, which actually then also affects the housing or the pin material, and you will find the power loss. So this is now as you may remember in KISSsoft, this was some coding was there actually needed, and this is now available as a functionality as such. Let me now continue with the topic of the gear body. As Ilya mentioned in the very beginning of this webinar, we continued in the KISSsoft software with gear body calculation and representation. And you can find here two examples of gear bodies. One gear body is defined by a step file and represented now in the shaft calculation as well. However, keep in mind that 2D cut in the shaft editor is represented by a symbolic display, whereas for a manually defined gear body, in the gear calculation, we can see the exact shape in the shaft calculation as well. So now the gear body is now consistently displayed in the gear module, in the KISS design module, and in the shaft calculation. Of course, what is on major interest is about the effect of the gear body on the load distribution. Let me show you on that one in an example. I will use the manually defined gear body as it just gives a faster calculation of the FE. Here we are, and now we are in the shaft calculation, and quite a good module, I like it quite much in KISSsoft, is the flank line modification. The flank line modification gives us the information about the individual effect of the shaft itself, considering the counter shaft as a theoretical shaft. So we can learn here about the deformation and the effect of this single shaft directly. Let's have a look at the results now and watch carefully. The FEM calculation was done very quickly in the very beginning of that calculation. It means that now this configuration, this considered gear body leads, and this is a bit, let's say, incidentally, to a very balanced load distribution. So, and we can compare nicely now to the situation where the gear body is not considered. Let's do so by saving the current line load. Then we simply now unclick the gear body stiffness and we repeat the calculation. We can find the current load distribution now as follows. Now we have an increased phase load distribution, means an unbalanced phase load distribution, which results in a quite larger value. So this is how to handle in KISSsoft, and also how connections of the calculations are designed in KISSsoft. As a next topic, let us have a look at the bearing, the roller bearings, and what has changed to the new release. As a part of our job as a software supplier, for each release, we do an update of the rolling bearing database. Rolling bearing database are provided by the manufacturers here, for example, SKF and NSK to us, and it's let's say a continuous work for us to update it and to provide it for you as users to have updated bearing lists. Also, some smaller improvements are done for rolling bearings, and you can find them in these slides. Let me continue with shaft hub connections. For shaft hub connections, we added a rating calculation for crowned splines, and we added it according to literature from Dudley. Maybe you know Dudley as a literature, and we found that Dudley literature is used still today quite much in the aircraft. So obviously this literature gives reliable and a quite good dimensioning method, which is implemented now in KISSsoft. Let's have a look at an example. So again, this is a spline or curved tooth coupling, and when using ACMA method with the type of misalignments and number of revolutions specified, we will find then in the report in the strength section. Let me go here and let me make it larger and easier readable. So let's find here the results according to Dudley. So this is now available in the current release 2024. As the next topic, I would like to mention about some improvements in the script programming language. As you may know, the script programming language is also the successor of the KISSsys class card programming language, and furthermore, it is implemented now in all the KISSsoft modules and not only the KISSsys. So let's see what is new, and therefore I would like to show you the debugger functionality. The debugger functionality works so, and there is a file prepared. It's a simple gear pair calculation, and there is a script provided which does a variation of the phase width, and there is a loop integrated where the phase width increased until the safety numbers match the required safety numbers. What we can do now as a user, we can now define a breakpoint. So let's say we wanted to debug this code because we assume there is a bug inside. And what we can do now is we can go step by step through the code, and we can see in the new view of debug console, we can see intermediate values, for example, safety numbers and the iteration step, which is currently 0. But when clicking through the code, we can find updating these numbers, go through the various steps in the loop. As you can see here, the number is increasing until the loop is finalized. So this is how you can work with a script and with a debug mode which is actually comfortable. One more point I would like to show you is how we recommend to use script. And one of the possibilities and application for script is to create or to integrate an own tab into the KISSsoft user interface. By the script functionality now, I created here one more tab which provides me an specific parameter what I'm interested in, and which I did normally by an external Excel spreadsheet, for example. So so far I typically did two calculation steps, one in KISSsoft and one in an external Excel spreadsheet, just to get my results as I'm used to get it. What I can do now and what I did here, with the script functionality, I integrated now this external calculation into the KISSsoft calculation. So now it is in one tool and I get both the results in the same, the standard as from KISSsoft and my individual calculation, which I needed to do previously in a separate tool. So this is a quite uncomfortable approach that you can integrate your own calculations into the KISSsoft. If you have any questions about the scripting, if you have a question about how to create the code, how to do what is a variable, and to be honest with you, I'm a mechanical engineer. I'm not a programmer, so I can strongly recommend then that you visit or you join a training what we offer in this year, the first time, about scripting. There you will learn about what is a variable, what is a meta variable, which variable can I have in my report, and things like that. And a last point in this topic, when you press F1, which means the help functionality, you will find now in the manual, you will find now a big list of variables, of parameters, which you will need in your script coding. And by one click, you can access these parameters very easily. So you see there are some improvements in scripting provided. Okay, so as a last point, and we are also time-wise close to end, I don't want to take too much time of you than this hour. Let me have a quick, a short word about bolt calculations. Bolt calculations are, let's say, after the mechanical or the machine elements, the gears, bearing and shafts, one of the most important elements to calculate. And also in this module, we continuously improve the calculation. For example, now we added a more accurate calculation to consider an additional bolt moment. Let's add here 5 or 7 Newton meters. And we find now in the current release a more accurate algorithm to find the effect on safeties, yield point, and fatigue failure. So when now these moments are defined in KISSsoft, we can find a significant drop of the safety values, and this means now it is possible to consider the moments more precisely in the safety results. So, and with this table, I want to end my presentation, and I want to thank you for your attention. Ilya, please take over.
Jürg, thank you very much for this excellent presentation about all the new features. We really hope that you have received a nice overview of what's new. And right now, let us focus on some customer questions. And I hope that maybe they are also interesting for all other participants. So, Jürg, I will start with question number 1. Can KISS Design output the system level backlash? Or also, can it output system level torsional stiffness?
Yes, it does. It does. It gives the value in the main report, actually. In the main report, when you do a KISS design calculation, and so just go on a easy example. This is the same as it was in KISSes before. And this actually is a quite good information for the design engineer. So we can find the results directly in the report, in the main report, and there it's called auxiliary results. Let me make it larger. Here we are, and we can find system torsion and system backlash. So, and we can find here there are some translation issues. We can find here mean max value for backlash and for the torsion itself. Yes, please. This is available, right?
But I suppose most of our English-speaking colleagues, they are perfect in German as well, right? So Spiel and backlash, it's a synonym. Okay.
Sure. And otherwise, please ask our support. That's a good chance.
Thank you, Jürg. Next question. I will read the question. I'm not sure if I understand it, but I will read it. Can we simulate also position of the reaction rod on the gearbox housing if it's fixed to the ground?
We need to look at it in detail. It is the stiffness, actually, the casing stiffness. No, not in KISSsoft, I guess, not in KISS design. In KISS design, we consider the effect of the deformation of the housing and the effect on the bearing and shaft positions. Yeah.
Okay, thank you.
I don't think we do so. However, please let us know if you wanted to do so.
Also, we have some recommendations for improvement in the FAM tool. However, we will not speak about improvements today. However, you're always welcome to write us an email if you feel like there is potential to improve the calculation capabilities, and we will catch up on that, but not here, but per email. Next question, Jürg. It's about FEM. We are both FEM experts, right? So for the FEM calculation, what type of material models are used? Can plasticity be modeled for polymer gears?
Spontaneously, I would say no. I don't think that the FE mesh what we use is. I think it's on a elastic theory applied, but we will give more exact answer by email, I guess. Let us give this question to our expert, right?
Yes, I agree. And last question before we end this webinar. In asymmetrical gear body shape, is the influence of the interference fit somehow considered or implemented in the software?
No, there is no. The interference fit and the way how the gear body is assembled on the shaft. This is in a separate calculation. We consider in KISSsoft, we consider an theoretical fixation of the gear body on the shaft. I would say so, at least.
Right. So, and then we come to the end. So let us say a big thank you for all the participants. Thank you that you were here. We hope you enjoyed this presentation, and please let us know which top 3 features you liked about the release. From my side, I say thank you very much. Have a nice day, and as always, the last word is on you.
Yes, thank you, Ilya, of course. And thank you for participating in this webinar. And let's start now with release 24. Thank you very much and have a nice day. Bye-bye.